we are looking for two numbers, m and n, such that ax squared plus bx plus c is equal to 1 over a times x plus minus m and ax minus n. Okay, so if I distribute this, I get ax squared minus amx minus anx plus mn. All of this is a detail to show you that this is possible. And this is from the internet. Okay, I didn't do that on my own. So I get this in the form of ax squared minus n plus n x plus 1 over a m times n. So negative b is n plus n, and mx over n over a is equal to the number c. Ax squared plus bx plus c. The above proof is derived from, and you can look at the site here. And before embarking on the algorithm, we decide on the sign convention. If m and n are both positive, both negative, or opposites. Okay. I'll show you what I mean by that. The product is, in the algorithm that I'm using here, the product is a times c, the product of the two numbers I'm looking for, m and n. The product is a times c, and the sum is b. And this was the proof why this is so. Now there are two possibilities. Both the product and the sum can be positive, one positive, one negative, or both of them can be negative. The trick is the sign of the sum is always the sign of the larger number. Smaller number on the left, large number on the right. The sum is positive, is negative, the large number is negative. The sum is negative, the large number is negative. The sum is positive, the large number is positive. Now, if the large number is positive, the small number must be positive also, because a positive number times a positive number gives us a positive product. A negative number times a positive number, a negative number times a negative number gives me a positive product. This has to be negative. A negative number times a positive number gives me a negative product. A positive number times a negative number gives me a negative product. Once you have the sign convention correctly, it will be much easier to get to the numbers as quickly as possible. For case 1, as I said, the sum is positive, so the other number must be positive also for the product to be positive. And for case 2, well, I just went over it up there, so this is just a repetition of what I just told you. Okay. Now that we know the signs of the two numbers, we systematically work with the divisors or factors of the product, starting with 1. The small number will be 1, 2, 3. If 3 is divisible, is dividing into the product, and so on. Some students are good at factoring trinomials by just looking, by inspection. I don't have that capability, but I have an algorithm that works every time. If you are such a student, you can just look at the problem and say it factors like such and such, be my guest. You don't have to do it this way, but it might be a good idea for you to learn it. Because if you want to convince somebody that factoring cannot be done, you cannot just go and say it cannot be done because I don't see numbers that work. What about the numbers that you can think of? But if you run through all the possibilities like I'm showing you here, you have proven that it doesn't work.